So I'm here in Waterloo, Iowa, and try out the NACS supercharger adapter that I just received. This is a genuine GM approved one, and in other words, it's made by Tesla. It looks like just like the Rivian one or the Ford one. So I'm going to try this out and see how it goes. One thing I like about this charger is no matter where you park, you still block 2 stalls. But what's nice is the charger is right next to the charging port on the Blazer. So same as the other one, I'm gonna have to set down the phone here to do this, but I will plug this into the cord and then plug it into here and start the charging. This GM thing can be a little finicky. There we go. I'll help it out. It was stuck a little bit. So, take the Tesla plug, plug it into here, and that goes in really easier than the A to Z, I think. And then I got to remove the little plug cap here, which is the stupidest thing ever. And then I'm going to plug this in here and tell it to start stall 1D. With the car plugged in, I come here and do find charger. Pick the nearby one, assuming you allow location preferences. And then charge here. And 1D, start charging. I heard the click, initiating charge. Fan is cooking up. It's actually charging. I don't know why it hasn't updated. There it goes. So we're ramping up. So far, this doesn't go as fast. Oh, there it is. 146 kilowatts. At about 11%, and I'll let this run for a while. I'm going to turn off the screen recorder, and you'll just get the average charge time at the end. So the slick thing with GM, when you're charging, if you get in the car, this power meter, this is the regen braking / power meter when you're driving, and it always tells you the instantaneous power. Well, when you're charging, it shows you the instantaneous charging power, so it's kind of a neat feature. 149 kilowatts. You can also get more information going home, charging, and then the top button there, I believe. And this will show you the current charging status with your pointless rate here and percentage and current range. This is valuable. This serves no purpose. That's helpful, and that's helpful. So we're maxing out at 151 kilowatts. But again, I'm not expecting any difference in the preconditioning. So it must just be an understanding of how it works. Like, it has to be cooler before it'll do anything. And it won't heat it as high as like Tesla goes. It just heats it enough that it can charge fairly quickly. So here at 30%, we dropped down to 126 kilowatts. It was at 138 kilowatts until just a second ago. So it's not doing too bad. It did 20 kilowatt hours in less than 10 minutes. So 21 kilowatt hours. We'll see where it is at 10 minutes. And I have been averaging driving efficiency of Oh, it cleared it. Shoot. It was like 2.6 maybe miles per kilowatt hour. So 20, a little over 50 miles range in that first 10 minutes. I'll let the screen record for a while here because then we can see the ramp. So far, no other Teslas have showed up here. There's also a couple CCS chargers and no one's using those. So it's really quiet. The station can be kind of busy, but it's just in Iowa, it's pretty spotty when they're busy. Probably rush hour or something. Overall, this Tesla adapter is working pretty well. It's a little easier to use than the A to Z. The A to Z is a little tighter plugging in, and it's like not as obvious how to unplug the Tesla part of it. On the A to Z, it's easier to unplug the Tesla adapter when the adapter is still in the car. So if you press and hold the button, it's easier to pull the Tesla adapter out and then pull the CCS out. It makes it a little easier to get out of the car. The Tesla one has two releases on it. One release is for the CCS and the other release is for the Tesla side. So it's really obvious how to use it. We'll see if this one crashes in power too. And what it does, when it does crash in power at like say 15 or 20 minutes, I'm assuming it will, I'm going to try swapping to the A to Z plug to see if I can continue faster, just to see if it's in the plug or if it's in the bus bars on the battery. My hunch is that it's in the bus bars on the battery because the A to Z never felt hot. So we'll see if this one does any better though. Or I guess the other thing it could be is if the cell temperatures are getting too out of balance, like the cells are not uniform temperature or something like that. But these are not cylindrical cells, these are pouch cells. Or maybe prismatic, I'm not sure, I'll have to look that up. The difference is subtle. Prismatic cells are just in a hard container and pouch cells are not. The area in Waterloo has a lot of gasaholics. I hear the engines revving. So we're still at 122 kilowatts at 40%. I think it's usually around 15 minutes that it will start slowing down, depending on what charge it started at. So what I've noticed in Iowa is the chargers are busy over the weekends. Turn my headlights off there. So you notice the fastest way to travel with an EV here is, especially one like the Blazer that charges fast for 15 minutes and then that's all you get. So the fastest way to travel with this type of vehicle is to wait for it to crash here, and as soon as it crashes, just go on to the next charger, because then the battery will have time to equalize temperature and be in a good state by the time you get to the next charger. So, and you'll be at a low state of charge again. So right now, at 15 minutes, I'll call it out, but I'm looking to be the same as I usually am, which is I think 35, 36%, and about 32.5, 33 kilowatt hours. So that amount will get me maybe 70, let's say 75 miles, just rounding a little bit. And 75 miles will get me to the next charger in most cases. So, and that's an hour of driving. So it's stopping a little frequently. Like, I don't like to stop every hour, but if you stop every hour, your charges are only 15 minutes and you can move on. If I stop every 2 hours, my charges are going to be more like 40 minutes. So it's just, it may not be much faster, but it is a little quicker to just, especially if the chargers are easily accessible, to just stop every hour. But again, you probably shouldn't leave until the charge starts tapering significantly. Like right now, it's still at 121 kilowatt hours. Even though in the 10% challenge, I would have left at 15 minutes, which was a little less than a minute ago. So, you know, realistically, you stay until the charge starts slowing down. Maybe this plug's holding out a little longer, but maybe not. It'll be around 50%, I suspect. Unless all the software updates made it different. My car has had a lot of software updates. Dealer had it a day and a half. Some of them take like 3 hours or something. The problem is that GM, like Ford, you know, they use all sorts of different vendors for their different computer systems, so it makes it a lot harder for them to update everything over the air. And, you know, they did that by design to make it more cost competitive. So they make, by bidding different vendors against each other, they reduce their costs. But at the same time, as it increases the system's complexity to have, you know, 50 or 100 different computer vendors in your car. So they created their own problem there, but they were solving a different problem at the time. But they need to change their architecture to be all one vendor, right? You know, GM should really own that. So we'll see if those software updates improved the battery charging at all. More revving vehicles. So 40 kilowatt hours, that'll be 100 real world miles. And I say real world miles because I can get about 2.5 at 75 miles an hour. So 2.5 miles per kilowatt hour at 70 miles an hour. So 40 is basically 100 miles. I'd like to be able to drive, say, 120 miles between stops. Rarely do I want to push 200, but you have to have a full charge for that. Still not a single Tesla here. That's surprising. Even in Cedar Rapids, I've always run into one. $100 kilowatts. Oh, now we're crashing. So yeah, it took it just 20 minutes. So I'm gonna go feel the plug temperature. and maybe switch to the A to Z if it's getting hot. But that's not bad. So this is where I would leave in a charge. And like I said, that got me about 100 real world miles, back down to 10%. So that's a good spot to leave. 20 minutes even. Okay, time to go check the plug. So I'm moving over to the other station here. Use my front camera to see how far I can pull forward there. That should be good. And I'm gonna switch to my A to Z plug and switch stations because the Tesla plug was getting hot too. Oh, time to complain to GM about that. It wasn't very positive on the... There it went. Okay. You want to make sure those locks click. The problem was the Tesla plug wasn't quite in all the way. Okay, I'm going to stop this video and switch. That sounded better. Yep. Okay, so the ATZ one's a little less positive. You just got to make sure it's all clicked together, right? We'll see if it's any faster. So interesting. Yeah, it made no difference. So the plug was fine. The issue is something inside the battery or car itself. Probably, like I said, bus bars, or where the current's flowing into the battery pack. Or it could be just cell temperatures as well. Without detailed diagnostic information of cell temperatures and such, you can't really see much. Unfortunately, GM has encrypted the CAN bus on this vehicle, so it's difficult to get access to that system. There's probably ways, but I don't know of them, and they probably are not free. So with that, I'll let it charge through the slow part here just to see how it does. Surprisingly, this stall still has signs that say Tesla parking only or 30-minute general parking. I'm surprised they haven't updated those. So yeah, if you don't want this slow down, leave by, say, 20 minutes into the charge. and then let this sort itself out while you're driving. This isn't as bad as it was the other day, but like I said, I need to do another multi-charge day because to see if it gets worse with each progressive charge throughout the day. But I actually don't need this charge, so I guess we'll see how long I end up staying. It's still going 80 kilowatts, which isn't slow. When it drops to 50 kilowatts is when it's bad, and that maybe moving prevented that. This is with a cold cord and a cold adapter. Whereas the other day when I had problems, the plug was directly in the sunlight, and it was really bright sun and really hot. So, it causes that plug to heat up a lot. And again, still no Tesla driver in like 40 minutes. Well, 30 minutes. Yeah, just out of the fun of it, I'm feeling the plugs in the wires in the Tesla branded adapter, and they're too hot to comfortably hold, so the adapter was getting hot. I bet the drop below like 80 kilowatts is the adapter, not the car. And the Tesla plug is equally as hot, right? Because it's building up the same heat that's in the adapter. So maybe inadequate cable cooling. The adapter is not cooled independently, so that's also an issue. Whatever cable cooling is there should help cool the plug or the adapter indirectly through the metal contacts. But this drop to 80 kilowatts, 75 kilowatts seems to be GM side. So it's an interesting thing you could maybe do is have a couple of those plugs on adapters on you and just swap them out when it starts to slow down. But you should probably swap chargers too, because like I said, the cable gets hot along with the adapter. Well, I got like 42 kilowatt hours before, and I'm up to 10 kilowatt hours now, 11, so 54 kilowatt hours, 53 kilowatt hours, and 57% charge in less than 30 minutes. So that's not bad. So if we can get 60% charge in 30 minutes, that's pretty reasonable. That's like 150 real world miles. But, sitting here, this whole second 10 minutes has been less than 80 kilowatts. So you're still better off probably to just leave and hit the next charger, as long as there's plenty of chargers. But every time you hit a different charger, you're running into a failure point, right? Like either the charger's busy or it could be down or whatever. So hitting fewer chargers is a little easier that way. So yeah, 58% of the battery charged in 30 minutes. Total of about 54 kilowatt hours. Man, I've never seen a quiet charger like this. So yeah, this charge is going to average about 75 kilowatts, and the first 20 minutes average over 100 kilowatts. I think I'm going to call it because I don't want to be here all night. And I'll do, I'll do some more charge testing on CCS chargers. I saw some lightning over there. I'll do some more testing on CCS chargers that don't have the adapter variable in the mix. Overall, the adapter works really well. Definitely get yourself one if you plan on road tripping a lot, because Tesla chargers are just easier. You can get a membership to them, and I would try to use almost exclusively Tesla chargers if you can, because the membership makes them a pretty good deal. And you can also get a membership to EA and stuff, so feel free to get a membership there instead, or both. But the memberships I would only keep it while you're road tripping. They cost like $13 a month, but the thing is you just get it month by month when you want it, and that $13, you'll save that in about two full charges. So it'll pay for itself on one road trip easily. So if you a longer road trip where you might charge 5 or 10 times. So every time I go back to Wyoming, I charge maybe 10 or 12 times total. So it'll save me itself several times over, and definitely worth getting. So with that, I'm going to cut it off here because it's going kind of slow. So, okay. Thanks for watching.